Stoichiometry. It's the study of the amount of reactants and products in a chemical reaction. And basically, if we know the amount of one chemical, we can calculate the amount of another. And this is using a balanced chemical equation which gives us the ratio of moles which are reacting. Here's a reaction written out for you. It's a balanced chemical equation. We can see here that if we have 1 mole of iron sulfate, it reacts with 2 moles of sodium hydroxide to form 1 mole of iron hydroxide and 1 mole of sodium sulfate. It will always react in these ratios. So if we're told we have 0.5 moles of iron sulfate, we know that we will need to react that with double the amount, because here we have 1:2 ratio, so we will have 1 mole of sodium hydroxide reacting with 0.5 moles of iron sulfate. These are a 1:1:1 ratio, so you'll have the same amounts here, 0.5 mole and 0.5 mole. If we're told that we have got 5 mole of sodium hydroxide, we know that it reacts with half of the amounts, so we will have 2.5 moles of iron sulfate, and that will also produce 2.5 moles of iron hydroxide and 2.5 moles of sodium sulfate. These ratios do not change. So the first step with stoichiometry is to write your balanced equation so that you can find these mole ratios. Using the information given, you identify the species that you know information about and the species that you're trying to find information about. So the species that you know is called the known, and the other one that you're trying to find out is the unknown. You calculate the number of moles of the known using the information given. So once you've got the number of moles of the known, we can then use the mole ratio, so it's a 2:1 ratio, to then determine the number of moles of the unknown. So once we've got the number of moles of the unknown, it's simple just to work out the unknown's mass or volume. Mass to mass stoichiometry. If you're given the mass of the known, you can work out the number of mole of the known. You can then use that mole ratio to work out the number of moles of unknown and then work out the mass of the unknown. I'm going to take you through a couple of examples step by step. When a piece of zinc is placed in silver nitrate solution, it slowly corrodes and crystals of silver grow on its surface. If 5 grams of zinc is added to excess silver nitrate solution and eventually totally dissolves, what mass of silver crystals will be produced? So let's look at the information here. If 5 grams of zinc, and they're trying to find out what the mass of silver crystals produced is if 5 grams of zinc is reacted. So we know this information, so zinc becomes your known species. The mass of silver is what you're trying to find out, so this becomes your unknown. So write down the information that you know about your known. We know that the mass is 5 grams, and we know the molar mass from the periodic table is 65.4 grams per mole. We're trying to work out the mass of the unknown, and we know the molar mass from the periodic table. So we take this information here, and step 2 is to calculate the amount of the known in moles. So if we've got little m and big M, N equals M on M, which equals 0.0765 mole. Now that we've got the number of mole of zinc, we can work out using mole ratio, remember it's a 1:2 mole ratio, how many mole of silver there'll be. So the best way to do this is to use unknown over known. You can't go wrong if you do this. So the number of mole of silver equals the mole ratio of unknown over known. So the unknown is 2, the known is 1. So we have 2/1 times the amount of zinc that we've just worked out, which is your number of mole here. So that equals 0.153 mole. This is a really good point just to double check your information. So I know it's a 1:2 ratio, so the amount of zinc here needs to be less, or it needs to be half of the amount of silver that I've just worked out, which it is. Step 3 is, now that you've got the number of mole of silver and you've got your molar mass, we can just work out the mass of silver using N times M, and we'll get a mass of 1.67. Again, I like to check my answers, so we'll go back to the question and just to make sure that we found out the right thing after all those calculations. So it's asking me here for the mass of silver, and I've found out the mass of silver. So I'm correct. A second example. What mass of magnesium oxide would be produced when 10 grams of magnesium is burnt in oxygen to form solid magnesium oxide? First step, write a balanced chemical equation. Here it is here. Second step, have a look at the information in the question. It's telling you that there's 10 grams of magnesium, so this is your known amount. And it's asking you to find out what mass of magnesium oxide will be produced. So magnesium oxide is your unknown amount. Put in the information that you know. So we know the mass is 10 grams. We know the molar mass of both the magnesium and the magnesium oxide from the periodic table, and we're trying to find out the mass of magnesium oxide. We can work out, using the mass and the molar mass, we can work out the number of mole of magnesium by M on M, and that will equal 0.412 mole. Now that we know the number of mole of magnesium, we can then work out, using mole ratio, the number of mole of magnesium oxide. It's a 2:2 relationship, so the number of mole here is going to be the same as the amount of magnesium oxide produced. I still like to do the formula. So we've got unknown divided by known times the number of mole that we've just calculated, 2 divided by 2 times 0.412, and that will equal 0.412 mole. Double check your answer at this point again. 2 magnesium creates 2 magnesium oxide. Yes, my answers are the same, so that's correct. I then use this mole that I've just found out to determine the mass of magnesium oxide. Mass of magnesium oxide equals number of mole times molar mass. Plug in my values and I get a mass of 16.6 grams. Go back to the original question and double check that you have calculated the right thing. Mass and mass we have, so it's correct. Here's a question for you to have a go at. So what mass of, the first thing it wants you to work out is lead oxide, and then secondly oxygen. So what mass of lead oxide and B oxygen are produced by the decomposition of 8.4 grams of lead oxide according to the following equation? I've given you the equation. Pause this, have a go. I'll pop the answers up and then I'll run through the solutions. Okay, so hopefully you got an answer of the mass of oxygen was 0.602 grams and the mass of lead oxide was 7.84 grams. If you got that right, well done to you. You don't have to watch anymore. If you didn't, or you just want to go through another example, I'll go through it step by step. Okay, so information in the question here, we're trying to find the mass of lead oxide. So this becomes your unknown. And we're told that we've got 8.4 grams of lead-4 oxide. So we pop in the information that we know. 8.4 grams, and we can work out the molar mass from the periodic table. We're trying to find the mass of the lead oxide, so we can work out the number of moles of lead oxide by N equals M on M, and we'll get the number of moles equals 0.0351 mole. We then use this mole here plus the mole ratio to work out the amount of lead oxide. So the number of mole of lead oxide equals unknown over known times the amount that we've just worked out. Unknown is 2, known is 2, so it's 2 divided by 2 times the number of mole that we've just calculated for the lead oxide, and it will be equal to 0.351. Check your answer. 2 to 2, so it should be the same. Yes, it is. Use this amount of mole here now to calculate your mass. So M equals number of mole times molar mass, which equals 7.84 grams. Part B asks you to work out the mass of oxygen. So this is now your unknown, and our known stays the same. Now we've already worked out what the number of mole was. And there it is there, the number of mole is 0.0351 mole. What we are trying to find out that's new is the amounts of in grams. Oxygen, we know it's molar mass. Now remember, we've got a new mole ratio, it's 2 to 1 ratio. So we need to calculate the amounts of unknown over known, which is 1 divided by 2 times the number of mole of lead oxide. 1 over 2 multiplied by that equals 0.01786 mole. Have a look, does it make sense? It's a 2 to 1 ratio, so we should have double the amount here to what we have here, which we do. We use this number of mole that we've just calculated to now work out the mass using N times M, and it equals 0.562 grams.